Hi there, my name's Peter Marshall and welcome to this talk entitled Shape Incoming Data Effectively. These tips and tricks talks have been created to share our experience here at Imply with those of you who may just be starting out with Druid. If you have any questions, don't forget, register on Druid Forum and we will meet you there. This talk has two parts. First, what components might live around Druid in a Druid-powered architecture, and secondly, we're going to dive into some techniques to prepare your data for the kinds of analytics you're going to do using Druid. So let's start by looking at this rather beautiful slide where we're going to build up a generic model for a data pipeline that delivers modern analytics applications. On the left-hand side, we've got our producers. In the middle, the components that get us the data to the application. So delivery and storage mechanisms, processing engines, and of course a choice of database to power the app, which for us, of course, is Apache Druid. And on the right hand side, our user interface, that thing we're going to buy or build to deliver data to the user. Apache Druid can connect to streaming real-time sources like Kinesis and Kafka, and to long-term storage systems like S3, Google Cloud Storage and Azure Blob Storage. I can pull in from HTTP, from popular relational databases, from local file systems, even another Druid data source. And what about that presentation layer? Well, this could be custom-built applications. Maybe you'll use Node or React or Angular. Desktop applications that have Druid support built in, including Imply's own pivot application, or data science tooling, whether that's notebooks or languages. Let's move on to the production side. What is creating this data? Well, in the wild, go and take a look at the community. Tons of things, whether they're open telemetry emitters, pixels in websites, all sorts of data. For you and I, though, data from those producers is never exactly as you and I want it. And even when it is how we want it, we still might need to do other treatment for the end user or for the database. So we have to have these processing tools. We might use them to intercept the data on the way to our database. We might create separate sources. We might just update what's in the source data. To build any application, you and I know that we need to prepare data ready for our database, ready for analytics, ready ultimately for the end user. So what things might we need to think about when it comes to working with Druid as our database? Well, of course, somewhere in this architecture we need a source for the data. But it needs to be data that's been prepared in the best way possible for the kinds of analytics that your end users are going to do through your application. Secondly, you need to make sure that the data is laid out in a way that suits the ingestion processes in Druid. Thirdly, you might want to bring a sense of harmony between the schemas that you'll get out at query time in your presentation layer and the schemas you're putting into Druid. And finally, you need to use something to front load repetitive processing so that those thousands of users who are going to use your awesome app aren't creating waste in the query processing. We're going to look at some elements of a query, and to do that we've got a set of cards that give you ideas about what you might do with other components, and it also highlights some things that you can do inside Druid. On purpose, they're quite detailed, so feel free to rewind this video or screenshot them and refer back to them at your leisure. We're going to start by looking at dimensions in the select clause. When incoming data is bigger, every database will need more resources to ingest it, store it, distribute it, and analyze it. Druid is here to help you build amazing user experiences, and it's important to remember that. It's different to, say, a query engine running on a data lake. Walk, therefore, through your queries regularly. Keep on looking at them. What dimensions are people actually using in the different clauses of your SQL statements? This is an area that an Israeli community member puts a lot of effort to. They reduce their query latency by nearly 75% by continually talking to their users and matching their needs with their actual underlying schema. You can be very specific in Druid in your ingestion about what dimensions to include and exclude, but you could shape that schema upstream, and that opens up the option of schemaless ingestion to you. Now, staying with the select clause, let's look at some things around expressions. And let's imagine that in your UI, you have the ability for your users to convert between Fahrenheit and Celsius. Yes, you can do that by executing a query in Druid by having this beautiful expression, nice and simple. But remember, Druid-powered applications aren't just serving one person, they could be serving thousands. You really need to think at scale when using Druid. It may not be a great use of resources to get Druid to do this temperature conversion over and over again for each of your 10,000 users. This is how I think about it. I look at my function and I say, is it fixed? Is it going to change? Or have I got some kind of like interface in my presentation layer that allows people to manipulate this function? Then I have to think about the input values. When do they change? When are those input values settled? Is it settled at ingestion time, for example? And of course, how then can I tell when the output value is reliable and settled? And finally, I think, well, how expensive is it to evaluate that function? Is it a really complicated function, or is it just the matter of converting from Celsius into Fahrenheit? Because that temperature conversion is not likely to change. The actual function won't change. So you could front load the evaluation of that function to an ingestion time expression, storing the values for each row in a new dimension in that row. And then I can just address that dimension at query time. But maybe for you, it's easier to maintain that expression, or especially if it's a complicated function, upstream and then send that result into Druid ready to go, which also reduces the pressure on the ingestion resources. You can read a lot more about the transformations that are available at ingestion time in the transform spec in the Druid documentation. Now let's turn to filtering. Let's talk about where clauses, when we're asking Druid to filter out data that we don't need and only give us back the stuff that we do. Indexes are really important to get right in Druid. They allow the query engine to trim data quickly and to build up results. So imagine you're building a really focused page in your presentation layer where a specific group of users is only looking at 500 status codes from a stream of what's very typical for Druid, 1 billion HTTP events a day. Now, by applying an index on that status code, I therefore get the results for that page back a lot quicker. But a better approach may be to create a dedicated table, and perhaps where that table is actually created using an upstream source that only contains those 500 errors. But why is that? Why wouldn't I just filter at ingestion time with a transform filter, let's say, or just use the index field? Well, on the filtering at ingestion time, if you apply a filter to select or strip out data at that ingestion time, Druid still needs the resources to be able to read every message from the source data, then accept it or reject it. So imagine if just one of the 1 billion rows per hour that's coming into your system contains a row that you're interested in, Druid still needs the power to read all of them. If you filtered it upstream, there's much less pressure on Druid's ingestion infrastructure. Secondly, consider that a dedicated table just for those 500 errors is going to be much smaller, and that the data in it will be more relevant. It will be more localized. And you could find that queries across the board on that table will execute much faster than a massive one with 98% of the records that you're not interested in. Druid has a second way of handling filtering, not based on row filters, but on entire segments of data inside the cluster. This happens when the queries are planned, and it's called pruning. It's a very effective technique for speeding up filtering. The first level of pruning is on time. you need to have a sensible time filter in your query. You have to think about what time period your queries cover. Longer periods equals more work for the query execution engine to do. Here at Imply, for example, our pivot UI has this wonderful episodic comparison page with visual overlays. And it's not just because it's awesome, but it's also because what we do is we create Druid queries that execute extremely quickly on short periods. What we don't have is a UI with a year's worth of data sitting there waiting for the query to execute. The second level of pruning uses how your data is clustered using secondary partitioning, with which you can apply in any batch task. With pruning at this level, entire segments of data will be skipped if it's recognised by Druid that they don't contain dimension values that it's interested in. And that is a very powerful technique when you have a very commonly filtered dimension, like a country code, or maybe an account ID in a multi-tenant table. Druid has massively parallelized ingestion. Incoming source data is split up and ingested in parallel by multiple tasks. Take a look at the payloads for each individual task. Become familiar with how Druid is parallelizing your ingestion. For S3, for example, Druid will allocate particular files to particular tasks. You may need to apply a technique that creates balance in the splits so that each of those tasks are equally productive and that from the get-go they are creating well-sized segments. In Kafka, that might mean using a technique to balance data across all the partitions so that you avoid having a set of partitions that contain all the data that would cause imbalance in the parallel ingestion. Now then, let's turn to the from clause, to tables. Many resources and configurations in Druid are associated with tables: information management, replication and distribution rules, your control over ingestion tasks, automatic compaction rules. Do you have a peculiar security or retention requirement for a particular set of data? If so, logically separate and secure the data into a dedicated table. Do you have data that's critical to business decision making? Maybe have a separate table that has a lot more task replicas and has a higher segment replication process set up in your load rules. And then of course you couple that with a highly available input source and network connection. Do you have late arriving or out of order data? Don't forget to test and apply either a manual or automatic compaction strategy to optimize your Druid segments. Aggregates next. Sum, max, min, average. Of course you can do this at query time. This is why Druid is here, and to do it extremely quickly. But you can also do these at ingestion time and make it even faster. This is a really critical technique in Druid. You need to learn about how rollup works. You might find that you can adjust your source data to make that group by operation that happens as part of rollup highly efficient. Maybe you would remove some superfluous columns or reduce the granularity of actual values of strings or numbers. And of course, the big hitter here for high cardinality problems especially is data sketches for count distinct, set operations and quantiles. Now, Druid can ingest sketches too, so you may create sketches upstream, which is particularly interesting for this theta sketch or the set operations sketch. You might find it really useful to have another data sketch in your data so that you can do intersections and differences in a way that you can't do by generating those sketches at rollup time. Let's talk about join operations. The high-speed query engine in Druid loves flat tables. In that scattergether engine, join and subquery and select in statements do hit an infrastructure bottleneck. To quote someone from the community, let Druid be Druid, let Spark be The aspiration for every developer using Apache Druid is a query that runs in under a second. So for those UI elements that demand lightning speed, use Druid and other architecture components to keep the from in a query to just one table. For example, denormalize upstream. Maybe use KSQL to add visitor demographics to the click data ahead of time. Or if you use Druid lookups, they're extremely efficient and very fast. Perhaps, though, you might need to employ a lookup expression in your transform spec to pre-populate the lookup values, rather than doing that with a join at query time. Funnel analysis is one of those places where this definitely applies, and by using a technique that's like those given on this slide, combined with providing data to Druid that's explicitly in funnel order already, you can make your funnel UI awesome and fast. Surprise! Some final notes. Lag and lead functions and the like are not currently available in Druid. You might need to provide that data to Druid rather than solving it inside. Secondly, some of you do not get lovely schema-aligned standard format data, telcos for example, and that means you might need to handle formatting and validation upstream. Related to that, consider cleansing data upstream so that those ingestion tasks and your users can rely on valid, verified data. Next, Druid is not a state store, nor is it an OLTP. Druid is an OLAP database, and as such it is not a place where you update individual rows, but rather individual time periods. Consider how you're going to do that and the cycle on which you will apply updates. Do you need to know the current state of an order or of a video streaming session? Remember, Druid is not a state store, so construct and emit data about sessions to Druid. Avoid trying to solve the sessionization problem with tons of subqueries inside a Druid query. If you've got any questions about what you've seen today, register on Druid Forum and raise a question. Say hi to us, we'll say hello to you. Visit learn.imply.io for Druid-related courses, and with me, please say thank you to the developers who are working so hard on the Apache Druid releases with a star on the Apache Druid repo on GitHub. Thank you.